Our authoring tool is Arethusa. Our team includes Lakshmi and Xinjie. The idea of our authoring tool, Arethusa, is based on the SIGGRAPH paper 2-scale particle simulation. And here is a quick demo of our result. You can see when the fluid hits the mesh container, we can get great details on the surface. Traditionally, the physical and the visual quality of particle-based solvers like SPH are defined by the number of particles that are used to discretize the fluid. And the design goal of Arethusa is to build a tool that can produce fluid simulation with surface details while improving the efficiency by reducing number of particles. With our authoring tool, we can produce small-scale details like small droplets, surface ripples with obstacles. And the main capabilities of the tool is producing fluid simulation of low and high resolution with surface representation, and it can also handle collision with obstacles very well.
This tool is based on 2-scale particle simulation. We use the Fluids V2 open source code to generate the basic SPH simulation. Our method uses a low and a high resolution simulation that run at the same time. The subset can be arbitrarily defined to capture complex flows and small-scale fluid surface details. The low and high resolution simulations are coupled by including feedback forces and defining appropriate boundary conditions and collision detection with the obstacles. We reconstruct the surface of the particles using marching cube and level set algorithms. We connect the vertex and face information of the reconstructed fluid to the Maya mesh and export it. This tool uses different strategy to optimize the performance by allocating resources to regions of fluid where complex flow behavior is exhibited. Here in the video, we have complex interaction with a mesh, which is defined in yellow. In the video on the top, the high resolution region is defined in yellow, and this region is computed with quadruple resolution. In our 2-scale algorithm, a fluid subset is determined in low resolution region, and this is additionally simulated with higher resolution. The particles of both the simulations can be merged for final rendering.
To use the authoring tool, first you select your container and set it as low resolution region. And then for the place you want to initiate your fluid, you create the volume and set it as set initiate fluid. And then you import your obstacles and click set obstacles. And for the region around the obstacles that you want more detail, you create another volume and set it as high resolution part. And after these are done, you can create the SPH node, and then you can see your fluid get initiated. And by clicking auto create or manually create frame by frame, you can see your simulation. And next is our final rendering.